Hello and welcome back. Today in module number 6, I will talk about 3 subjects. Before I will get into it, I want to talk about a textbook. Some of you came complaining that the price of the book is too expensive and they don't have access to it. So, the University of South Florida Library has 2 copies of the book. And so you can actually go to the library, it's under reserve. If you search for Show Me the Numbers, you will see it at the catalog and everything that entail. So that's my answer to those students and to those students who did not ask those questions. So what are we going to do today? First, I'm going to talk about what is deviation analysis. Then I'm going to start incorporating things about review principles for good design in Taboo. And I will also have an announcement about Taboo. I have someone who works with Taboo for a publishing company. And if you are interested to listen to his talk, please let me know. I will bring him into the school, but you will need to attend. So I will make a post about that. I want your reaction. If you are interested in someone who comes and discuss what he does with Taboo and will it help you, please let me know and I will invite the guy and I will set a date to it. And the third, I'm going to make more known principles about design. And I'm going to use Tofty. Tofty is a well-known historian about visualization that our textbook talks about that quite often and refer to it as the foundation of analytic design. So let's start with some statistics and some numbers for warm-up. So what is deviation analysis? According to our textbook, it is a measurement between the difference between any number in the set and the mean of the set. So example, he provided an example of sales versus marketing versus operation versus engineering and finance, and he gave us 2 sets. One is the mean and one is the actual money that they have in the account. So the variance and the standard deviation in statistics. When we have variance, we aim to measure how data points different from the mean. So what is the mean and median of the above data set? In first data set, the mean is equal 7 and the median is equal 7 also. In the second set, also the mean and the median are equal. So but we have in a sense that those 2 data sets are not identical. The variance show that how different they are with regard to overall performance. So when we want to find a way to represent those 2 data sets numerically, the variance is a good component or element that will allow us to do that. How do we calculate variance? There is a lot of not debate. There is a standard equation that will say that you need to have the x, the one number minus the mean divided by the total number of set in the equation in order for us to calculate the variance. But we also have population versus a sample. As I said in the past or in last module, population is the entire population of our audience, and sample is when you are taking a rough estimate of the population by using a sample that will represent the population. So the idea here is that the mean is called variance, and by doing that, we are able to calculate or to understand where is the variance in the population versus the sample, and by doing those comparison, we have better sense if those sample accurately represent the population. So example, the score. And how do we do that? And by doing that, we're going through x minus the specific set, and we multiply it by square. And in order for us to calculate the variance, in this case, 7.6. I hope it makes sense. I hope it is a good example. Example number 2. Mark, two people dive in, so we calculate the mean of those two set. We calculate the median, we calculate the range, but due to the outlier, the median is more typical of overall performance. Which driver was more consistent? This is something that we like to know. So the idea here is, again, we are putting it into a test, we are applying it, and by doing that, we can show that Mark has a lower variance, therefore he is more consistent with overall performance. Again, that's the power of statistics with regard to what is the consistent of the data. Another form that we need to talk about, and I talked about that in descriptive statistics, is the standard deviation, or the measurement of variance of score from the mean. So we have a sample standard deviation, but we also have to have, when we are taking a sample, we have to know also the population of the standard deviation. And another formula that we need to keep in mind is the formula of variance in a frequency distribution and the standard deviation of frequency distribution. Both formulas are different from each other. The variance, as I said before, is the calculation of the mean. The second formula is the standard deviation. And by doing that, we are able to, again, find what does it entail? Why is it so important? So again, the variance to the second driver, the standard deviation, and round of rule carry one more dimensional place when it present in the original data. We always like to see if the data can be shaped as a bell shape, which means that it is basically a normal distribution. So in the normal distribution, we have rules which is called bell shape, which is 68, 95, 99. So 68% of all the scores must fall within one standard deviation of the mean. The 95% of the score has to fall with 2 standard deviation of the mean, and 99.7 is the score fall within 3 standard deviation of the mean. So this is how we set up to see if our data has a normal distribution, and if it does, it has to follow the bell shape rule in order for us to do that. But again, I need to convert this idea into visualization. And again, this is the interesting part. Which one of the two visualization is a better choice to represent what we are trying to do? Actual versus budget comparison, a most common example at deviation analysis. So in this case, north, south, east, and west. And what do you think works best? The annual on the left or to the right? Textbook says that the one of the to the right, the one on the right is the one that is really hard to read, because it requires the user or the reader to see what it entails compared to a more smoother ride onto the to the left. So this is again the idea of how do we apply basic standard visual representation in order for us to make our point more clear, to make ourselves more clear with regard to what we have, what we are trying to accomplish, and how do we do that. In R, we can do that too, and I'll teach you very soon about the R. The next, from now on, you're going to start reading the second textbook, and we're going to apply principles in R into visualization. But I want to summarize the idea of the deviation analysis and display. When you are using deviation analysis, you are compared to the current target. The example is the actual sale through today compared to what we're aiming for of today. Future target is the current year of the data website visit compared to your actual goal, or the current forecast, the actual sales in compared to what you expected, or this same point in time in the past, or the standard, which is the number of example manufacturer defects compared to the number that has been defined as acceptable. Those are the things that we are, according to our textbook, we use the deviation analysis in order for us to be more specific, more target towards what we are aiming to do. So, how do we apply that? Deviation analysis display not only the required fancy visualization. The two best graphic of this type is bar graph and line graph. In both cases, the graph that feature deviation should display as reference line the set of which the values over which is compared to. So it's really important to make this comparison, to make it more transparent in order for us to make our point using visualization more coherent to the user. So again, this is something that is really important, and I hope that in the future you will use it, and you will use the deviation analysis display as your part of your argument that you will put forward in the visualization display. Back to the software that we started to play with, which is Taboo. I'm going to take a little bit different approach now from what I did in the past, and I'm going to use other people's principles with regard to simple design in Taboo. And this is from IDSRC, and they came up with 10 data visualization tips to Taboo, which you can apply to any type of visualization that you do. So one of the principles requests that they say, keep it simple, as rule number 1. Rule number 2, have a specific message you want to communicate. Example, deviation, we want to compare one versus the other, the actual budget with proposed budget. Those are specific message that you want to select. Select the right chart form is things that we need to work on, and we are continue doing that even in any stage. We always look for a way to see how the data best fit into the type of visualization, from bar chart to line graph to ring chart. What can we do to make ourselves more transparent? Rule number 4 is use compelling headlines and checks to describe the way message of the visualization. So use the X's and the Y-axis to symbolize what it is entail. Tell us what you actually do, and provide an index or index of what is basically measured. And they came up with a specific recommendation. Include compelling headline, label the X's, use the deck to describe what is being described, provide sources of information to establish credibility. 5 is that where we are going to talk about that, and that's why I bring out Edward Toth into the discussion. Minimize the data ink ratio. And the issue of data ring, I will discuss that with how Tofty look at that and what formula he provides us to use. Rule number 6, avoid special effects such as 3D graphics. This is one of the points again and again that this book provides us and tell us not to use in order for us to avoid error, avoid misleading. 3D is a complicated thing. It's not as simple as people think it is, and it can mislead people to what actually is the data. So the recommendation, the general recommendation in the industry, and I cannot say I will not take points if you choose one, but you will need to provide a good explanation as to why I using 3D. 7, avoid hierarchy to your data, and again they use Tofty recommendation on that, and I want you to do that, to think about that. And 8 is use color, size, and position to help the reader to see what is important, and this is really important. And rule number 9 is to find the models that you like and use them in your design. And this is something that I want you to do. I want you to start looking at other websites, see what they did, see what is it important, why is it applied. And then 10, revise and re-edit. The whole point is that you're not doing it one take and you do the design or the visual analytic in one take and go home or eat a candy. No, you're going to go back and forth until you get something right, and this is something that is really important. Back to the main subject of our talk, which is Tofty. He's a theorist, which means that he came up with the idea of how can we learn from the history in order for us to produce better visualization. Most of his visualization and the reason that we are not discussing in this class is with regard to PowerPoint presentation. That's not my aim. I'm not aiming to teach you PowerPoint presentation, but we can take what he is talking about and apply it to our visualization or visual analytics in order for us to better and to conduct the visual analytics. His principles is 6 principles that are really important, and all of them I want you to go over that and see if it makes sense to you, and how the issue of integrity is play important part of his principle. This is something that is very important, something that is really key in his overall platform. So show the context is really important. One of the example that he shows is that if we will show, example, 100 combat deaths per month, and we will show only in Iraq, it will not make any sense. But if we will compare it to Iraq, to Vietnam, it will start to make more sense. And if we will also compare another data set, for example, World War II, and compare it to Vietnam and Iraq, now again it will make more sense. The end result of this visualization can be found in the New York Times, which did the following. This is the powered visualization. We are not just making a nice aesthetic, we are trying to tell a story. And by telling a story, we need to give more in-depth into what we are doing or what we have found in the context of what we are doing. Now to the rule number 3. Maximize the data ink ratio. And this is what it calls the lie factor. The lie factor, according to Tofty, is the size of the effect shown in graphics versus divided by the size of the effect in the data. So when this isn't 1, it is uncommon to be as large as 2 to 5. It is less to see a life factor than less than 1. So the recommendation is to try to be more transparent and to show everything, but to show that in proportion. If it's 1, it's usually you can delete it or not show it, but if it's 2 to 5, please show it in order for us to understand that. So again, this is the maximized data data inc ratio. Again, male versus females. And what does it really say to us here? When you are thinking about this, this is again in 3D. It might mislead us and show us basically something that we are really want to see, which is women are being paid less than men. And this is really important, even though the proportion here are not correct, are not displayed correctly. This is something that is really important to show and to display, because there is a lot of missing pieces. How many females are getting this high salary? How many males get this high salary? Why is men has less male who earns less than a female? Those questions, this infographic missing the point, and that's why it is bad. The third principle is to show the data variation, not the design variation, as we talked before. And this is a good example to avoid. Again, this misleading quarterly, yearly, and again, this is something that we are missing the point. It's too much information that we are missing the point, and the variation can be applied to it, but we are missing in the design, we are missing the point. Data density is another problem, and especially with regard to big data, we are trying to avoid data density and try to simplify it or to show it in more coherent way. But sometimes we are unable to do that. So just be aware that there might be an issue when we are trying to capture too much, and by doing that, we are missing the point. Then there is the Spark in the dashboard that is sometimes overwhelming. This is an example of stock markets, and each one of them, again, what does it stand? Which one is better? It's hard to understand what is better and what is worse, because we do not know exactly how to compare that. We do not have comparison. We do not have the variance in order for us to show, okay, Australia versus Canada, or AT&T versus Microsoft, or Microsoft versus Apple. We do not have this comparison. And by the end of the day, when we need to make the decision, we need to help the decision-making personnel to make a better decision. One of the things, again, that he repeats it again and again, avoid junk, chart junk, which means do not do things that does not look good. Example, in this example, there's too many lines. We are missing the point of what is this visualization stand for, because we have cross lines that goes across and we do not have a sense what is it really means. So in this example, it is much clearer that we can show in compared to this example. So again, clean design can help us to help other people to make better decisions. And again, before and after, again, a clean background sometimes help to make better decisions. Principle number 6 is a better representation. And again, the issue is he is very keen that you will show from the top, and in the bottom, which means that in this case, China is the leading, and that's why it ranked number 1, and this is what we will see. So those are the things that he's talking about. I hope it makes sense. I'm not going to keep on repeating them, but you will see that in your reading, in your work with different visualization application, those principles will go, even though they were designed for PowerPoint presentation. But nowadays, when we have much more power with regard to software application such as Tableau or open source R, it is important to understand what those principles are and examine if we can apply to it. So the principles, in, if I had to summarize it out of right now, above all else, show the data, maximize data ink ratio, eliminate non-data ink, eliminate redundant data ink, and revise and edit. Always revise and edit. It's not one take and you go home. You need to revise and edit until you get things right. When we are talking about design elements, we are talking about, again, going back in the context of this book. We talked about context, we talked about repetition, alignment, and proximity. And again, contrast before and after. Look at the difference. Look at, yes, the before we had a big belly with regard to nutrition, but the after, the white background make it very clear to us who is what is the leading obesity, and which is the United States. Again, this is a good design or use of design in order for us to show the elements. Contrast, again, mobile phone internet connectivity rate, and again, display the design element to show what is it entail. And again, the issue of repetition, this is really important, and I want you to see that, how to apply that and see if we can do that. I'm not sure that we will apply that in our class specifically, because we will talk about more about the analysis, but if you will need to repeat the same thing again and again, repetition is a key element. Alignment, again, before and after, this is according to Tofty. If you sort the data based on the highest to the lowest, it will make the reader better understand what you are trying to achieve or trying to display. And this is, again, based on PowerPoint presentation that we can learn about. Proximity is another way for us to display it, and it's important to do that. And again, the title give us the identity, what we are seeing here, in order for us to make more sense to it. So that's all for today. I hope you enjoy it. I hope that you will come back and ask for the speaker if you are interested to attend the speaker about Taboo and how does he works, and how, if you are interested and are willing to come to the campus to see it, please let me know, so I'll arrange his presentation before you. If not, we will continue on to our next destination, and again, that's it. That's all. Until next time, have fun.